So now what we're going to do is we're going to look at simplifying trigonometric identities by factoring, or just trying to look at and see what do they have in common, or can I break it down any further. So we're looking at number 17 in your notes. And I'm looking at this. I have tan squared minus tan squared sine squared. So I do see that they both have tan squared in common. So because they both have that in common, I'm going to take out a tan squared from both of them. I'm going to factor out a tan squared, which leaves me with 1 minus sine squared x. Okay? Now, like what we talked about yesterday, is whenever I see a 1 and I see a sine squared, I think of the Pythagorean identity sine squared plus cosine squared equals 1. Well, when I look at that, I know that's the same thing as saying cosine squared equals 1 minus sine squared. Okay? So what that means is that I can replace 1 minus sine squared with cosine squared. So now I have tan squared x times cosine squared x. Well, if I think about it, do I know anything else about tan squared? Well, I do know that it's sine squared x over cosine squared x. It's being multiplied by cosine squared x. So what happens is I see that both of those cancel, so I'm left with sine squared x. So what did I do first? I said, hey, do they have anything in common? And based off that common term, I factored it out. Then I used the Pythagorean. I looked at this and saw, hey, that looks like a Pythagorean identity. So I got rid of that 1 minus sine squared, replaced with cosine squared. And then I thought, hey, tan squared is the same thing as sine over cosine, which allows me to just get sine squared as my final answer. Let's look at a couple more. This is the same basic idea. I have sine squared times secant squared minus sine squared. Well, both of these have the same thing in common again, so I'm going to factor out a sine squared from both of them. And I'm left with secant squared x minus 1. Now, where have I seen this one before? Well, I know it's 1 plus tan squared x equals secant squared x. So then if I look at that, hey, that's the same thing as saying tan squared equals secant squared minus 1. So I can replace the secant squared minus 1 with tan squared. So I have sine squared x times tan squared x. Well, that's the same thing as me saying tan squared is the same thing as saying sine squared over cosine squared. So it looks like the only thing I can really do is say that it's sine to the 4th x over cosine squared. So let's look at another one. Now I know this is the same thing as saying tan squared, but one thing I look at here in number 19 is they both have secant squared, or they both have secants in the top and the bottom. So because I know that, I could say, hey, this is a difference of two squares. So I could say it's secant x plus 1, and then secant x minus 1, all over secant x minus 1. And when I do that, I notice both of those cancel, and I'm just left with secant x plus 1. So what I want you to do for class is try number 20, which is this one, and try 21. I'll see you tomorrow.